All right, let's talk about what's really going on inside your computer. Today, we're going to break down one of the biggest questions out there. What is the actual difference between a CPU and a GPU? Let's get right into it. So first, let me ask you something. You're looking at your screen right now, right? Have you ever just stopped for a second to think about how that image actually gets there? I promise you it's not magic. It's this incredible amount of work your computer is doing, dozens of times every single second. If you're watching on a 4K display, your computer is juggling more than 8 million pixels. But to create just one single complex frame of video, it might have to make calculations for over 16 million different things. We're talking light, color, shadow, you name it. That is a staggering number of tiny little jobs that have to get done in a blink of an eye. So how in the world does it pull that off? Well, inside your machine, you've basically got two different kinds of processors, two different kinds of brains ready to go to work. We've got the CPU and we've got the GPU. First up is the CPU, the central processing unit. Think of this as the master brain of the whole operation. It's incredibly smart, it's super flexible, and it can handle just about any complex task you give it, from running your operating system to opening your browser. Its specialty is thinking things through one step at a time, in a sequence. And then we have the GPU, the graphics processing unit. This is a completely different kind of thinker. It's not a jack of all trades, it is a specialist. It was designed from the ground up for pretty much one thing, to do with thousands or even millions of simple, repetitive tasks all at the exact same moment. This is what we call parallel processing.
To really let this sink in, let's use an analogy. Let's forget about computers for a second and step into a kitchen.
Imagine you've got a massive catering order. Your CPU is like a world-renowned master chef. This chef is a genius. They can bake, they can sauté, they can whip up an incredibly complex 7-course meal, all by themselves. But they work sequentially. They finish one intricate step before moving to the next. Now your GPU, that's like an army of 1,000 kitchen interns. These interns are not master chefs. In fact, they only know how to do one single thing, chop a carrot. But, and this is the key, all 1,000 of them can chop their carrot at the exact same time, instantly.
And this brings us right back to our original problem. See, putting an image on your screen isn't like cooking one complex gourmet meal. It's like being faced with a mountain of 16 million carrots that all need to be chopped in exactly the same way, right now. So, who do you hire for that job? The one master chef or that army of interns?
Okay, so let's apply this directly. Let's take our 16 million pixel challenge and see how our two workers would actually handle it. The master chef, our CPU, would get to work with its incredible skill. It would calculate the perfect color and brightness for pixel number 1. Done. Then, it would move on and do the same for pixel number 2. Then the third. It would do this flawlessly, but one after another, 16 million times. You can kind of see how this might take a while. But the army of interns, our GPU, takes a completely different approach. Its thousands of simple cores are like those thousands of interns. It assigns the task for each pixel, each caret, to a different core, and they all do their simple job at the exact same time. Boom! In a flash, all 16 million calculations are done. And this just shows you the result in black and white. For a massively parallel task like rendering graphics, the CPU is just too slow, despite all its power. The GPU, the specialist built for this exact job, gets it done in a fraction of the time. The difference isn't just small, it's absolutely monumental. So does this mean the GPU is just better? Not at all. It's about using the right tool for the right job. You wouldn't ask an army of carrot-chopping interns to invent a new dessert. And you definitely wouldn't ask a master chef to chop 1,000,000 carrots. Let's look at some examples. Running your complex operating system, that requires the sequential genius of the CPU. Rendering photorealistic graphics in a video game, oh yeah, that is a textbook job for the GPU's parallel power. Even something simple like loading an application relies on the CPU's ability to execute a series of complex instructions. But what's fascinating is that the GPU's talent for parallel math has found a new purpose in fields like artificial intelligence, where it can process huge data sets all at once. And that's the thing, the GPU is no longer just for graphics. Its ability to perform parallel processing on a massive scale is the engine behind so many of our most advanced technologies, from training the AI models that are changing our world to running complex scientific simulations and analyzing enormous sets of data. So the crucial point is this. It was never a competition. It's a partnership. The CPU is the director, managing the whole show with complex sequential thought. The GPU is the specialized workforce, executing millions of simple tasks on command. Modern computing relies on this perfect synergy to give you the experience you have every single day.
Which leaves us with a final thought. As our technological challenges, from AI to scientific discovery, increasingly look less like cooking one gourmet meal and more like chopping billions of carrots, which one of these brains do you think will ultimately define the future of computing? Something to think about. Thanks for tuning in.